Welcome to the deep dive. Today, we're diving into AI,
Oh, yeah.
specifically how to make AI think smarter, not just bigger.
Okay.
Our source, a research paper
Interesting.
with a title that kind of makes you question like everything you thought you knew about artificial intelligence.
Uh-huh.
Can 1B LLM surpass 405B LLM? Rethinking compute optimal test time scaling.
Yeah, that title alone, it throws down the gauntlet.
It definitely grabbed my attention.
Yeah.
We're talking about the possibility of like smaller AI models actually being better
Right.
than the massive ones that we always hear about in the news.
Yeah, yeah.
But before we get too far ahead, let's make sure we're all on the same page.
Right.
What exactly are LLMs? I know they're like the core of a lot of AI these days.
Yeah.
Could you explain it to me? Like I'm brand new to all this.
So think of LLMs, large language models, as the brains behind like those chatbots that you see online, like
Okay.
the ones that answer your questions or the AI that writes those like
Yeah.
really creative stories.
Okay.
They're trained on mountains of data and they use that data to learn patterns and relationships.
So more data equals a smarter LLM?
Generally, yes.
Okay.
We measure the size of an LLM in parameters, which you can think of as like connections in its artificial brain.
Okay.
More parameters usually means the LLM can handle tougher tasks.
So in this research, we have a 1 billion parameter LLM
Right.
going up against a 405 billion parameter one.
Yeah.
That's,
Quite a difference.
that seems like David and Goliath.
It does. It does.
Right.
You would think so, but that's where this test time scaling, or TTS, comes in. It's
Right.
like giving the smaller model a secret weapon.
All right, I'm all ears.
Yeah.
What is this test time scaling all about?
Imagine giving an AI like really, really hard problem to solve.
Okay.
Usually it has a certain amount of time to work on it.
Uh-huh.
TTS is like saying, hey, take your time, try out different ways to solve this, don't rush to an answer.
Mm-hmm.
It lets the model go deeper and consider more possibilities.
So instead of making the AI bigger,
Right.
we're giving it more time to think about the problem.
Exactly.
Interesting. But how do you make sure that it's not just like
Yeah.
wandering around wasting time? How do you make sure it uses that time effectively?
That is where the real interesting stuff comes in.
Okay.
The researchers use something called process reward models, or PRMs.
PRM.
Think of them as AI coaches that are guiding the smaller LLM's thinking.
Okay, now we're getting into the good stuff.
Yeah.
Can we get a deep dive definition
Sure.
of these PRMs? Like what are they and how do they work?
So PRMs are AI models that are trained to recognize good reasoning.
Okay.
Even if the answer isn't perfect yet,
Okay.
they analyze the LLM's steps and give feedback.
So they're not just looking for the right answer, they're looking at the entire process.
Exactly.
That's fascinating. But to put this all to the test, they needed a challenge.
Right.
And they chose math problems.
Yeah, they used problems from the Math 500 and AI Me 24 competitions.
Whoa.
We're talking about this.
Yeah.
The kind of math that would make most people
Pretty hard.
break out in a cold sweat.
Not your everyday math problems.
No, no.
And so they set up this AI math off with a smaller LLM,
Right.
PRM coaches, and these incredibly tough problems.
Yeah.
What happened? Did David actually beat Goliath?
Let's just say the results were not what most people would have expected.
Ooh.
And that's why this research is causing such a stir in the AI world.
Okay.
Yeah.
Interesting.
Yeah.
Welcome back to the deep dive. Before we left off,
Yeah.
we were about to find out if a 1 billion parameter LLM
Right.
could actually do better than a 405 billion one
Yeah.
using some clever tricks and
Yeah.
a little bit of AI coaching.
Yeah.
So what happened?
Well, the researchers found that with the right test time scaling techniques and effective PRMs,
Okay.
those smaller models were not just competitive,
Uh-huh.
they actually outperformed the larger one on these really challenging math problems.
Wait, hold on.
Yeah.
Outperformed.
Yeah.
That's a big claim.
Yeah, it is a big claim.
Are we talking about a slight edge or are we talking about like a huge difference?
No, a significant difference in performance.
Whoa.
Yeah, in some cases, the smaller models, when they were given more time to think,
Yeah.
and some guidance from the PRMs,
Right.
were solving problems that the larger models just couldn't.
So it's not just about the size of the model.
Right.
It's about how it uses what it has.
Exactly.
It's like that saying, work smarter, not harder, but for AI.
Exactly. This research really challenges like our assumptions about AI.
Yeah.
We often think that bigger models and more data are the key,
Right.
but this shows that efficiency and strategy can be just as important, if not more so.
So this has to have some pretty big implications for the future of AI, right?
Absolutely.
Does this mean we could see a shift toward like smaller, more accessible AI?
Absolutely. Like one of the most exciting things about this is the potential for democratizing access to powerful AI tools.
Yeah.
Imagine a world where researchers or educators or even artists have access to AI
Yeah.
that can run efficiently on like their own computers without needing massive supercomputers.
That's amazing.
Yeah,
It's like putting a supercomputer in everyone's pocket.
exactly.
Think about the possibilities in education, for example.
Oh,
You
totally.
could have personalized AI tutors
Yeah,
that can adapt to each student's learning style
exactly. Yeah.
and their pace.
That's just one example.
Yeah,
We could see AI-powered tools that help scientists analyze data,
right.
help doctors diagnose diseases more accurately,
Uh-huh.
even enable artists to create totally new forms of art.
It sounds like we're on the verge of a major paradigm shift
I think so.
in how we think about AI and use AI.
Yeah.
But I'm still a little fuzzy on the specifics of how this test time scaling works.
Okay.
Could you walk me through it again, maybe like an analogy or something?
Sure. So imagine you're writing like a really important email.
Okay.
You could just dash it off quickly and hit send.
Uh-huh.
Or you could take some time to revise and refine your message.
Right.
Make sure it's clear, concise, achieves its purpose.
Yeah.
TTS is like that revision process, but for AI,
Okay.
it allows the model to explore different ways of approaching a problem,
Yeah.
refine its reasoning, and come up with a more polished solution.
Okay, that makes sense.
Yeah.
But we're not just giving the AI unlimited time to think, right?
Yes.
There must be some kind of structure
You're absolutely right.
to this thinking time.
The key is not just giving it more time,
Yeah.
but guiding its thinking during that time.
Right.
And that's where those PRMs, those AI coaches, come in.
Right.
Remember, they're trained to recognize effective reasoning,
Yeah.
even if it doesn't lead to the right answer immediately.
So they're like mentors. They're helping the LLM develop its problem-solving skills.
Precisely.
Okay.
Think of it this way.
Yeah.
Imagine you're learning a new skill,
Okay.
like playing chess.
Right.
A good coach wouldn't just tell you the right moves.
Right.
They would explain the strategies behind those moves,
Mhm.
help you anticipate your opponent's actions,
Yeah.
guide you in developing your own chess sense.
Right.
That's what the PRMs do for the LLMs.
So it's like they're teaching the AI how to think,
Yeah,
not just how to solve one specific problem.
exactly. That's a great way to put it.
Okay.
And the success of this approach really depends on the quality of those PRMs.
Yeah.
Just like a good coach can make all the difference for an athlete,
Yeah.
a well-trained PRM can really unlock the full potential of a smaller LLM.
It makes me wonder,
Yeah,
how do you even train a PRM?
yeah.
What kind of data do they need
Yeah, that's a great question.
to learn how to be such effective AI coaches?
So training a PRM is a really fascinating process.
Okay.
It's all about teaching them to recognize good reasoning processes,
Uh-huh.
even if the final answer isn't perfect.
Okay.
Think of it like learning from the mistakes of others,
Right.
as well as their successes.
So it's not just about showing them correct solutions.
Right,
It's about exposing them to a variety of reasoning paths,
exactly.
both effective and ineffective.
Exactly. PRMs are typically trained on huge data sets of problems and solutions.
Mhm.
But here's the key.
Yeah.
They're not just given the correct answers.
Uh-huh.
They're also given examples of different reasoning paths.
Okay.
Some that lead to the right answer, some that don't.
So they're learning to recognize the hallmarks of good reasoning,
Exactly.
regardless of the outcome.
Exactly.
That's clever.
It is. And the training data for PRMs might even include steps that lead to incorrect answers,
Okay.
but which demonstrate logical thinking or a solid understanding of the concepts.
So even a wrong answer
Yeah,
can provide valuable insight into the thought process.
absolutely.
It's like analyzing the thought process of a brilliant but slightly eccentric scientist.
Yeah.
They might not always get the experiment right,
Right.
but their thinking can still be incredibly insightful.
Yeah, that's a great analogy.
Yeah.
By analyzing a wide range of reasoning paths,
Mm-hmm.
the PRM develops a really sophisticated understanding of how to guide the policy model
Okay.
towards effective problem-solving strategies.
I'm starting to see how this all comes together, but
Yeah.
we've talked a lot about these smaller models going
Yeah.
up against much larger ones.
Yeah.
Did the researchers actually compare these TTS-enhanced models
Yes.
to some of the leading AI systems out there?
Yes, they did.
Like the ones that are designed for complex reasoning?
Yes, and the results are pretty remarkable.
Welcome back to the deep dive. We've been talking about how smaller AI models with the right guidance can actually outperform those giants in the AI world.
Right.
And you were just about to tell me how they stacked up against some of the most advanced AI systems out there?
Right. So the researchers compared these TTS-enhanced models to some of the leading AI systems that are specifically designed for complex reasoning.
Okay.
Things like GPT-4o, O1, and DeepSeek R1.
Okay, just to remind me what makes those particular models so impressive.
So those are like the heavyweights in the AI world.
Right.
They've been trained on massive amounts of data,
Yeah.
have billions, even hundreds of billions of parameters,
Yeah.
and are known for being able to tackle really complex tasks.
So these smaller, more efficient models were going up against the chance?
Yeah, pretty much.
So what happened?
The results were pretty astounding.
Okay.
Even though they had far fewer parameters, those smaller TTS-enhanced models were often able to match and in some cases even surpass the performance of those larger, more resource-intensive models.
Wow, that's a serious upset.
It is.
It really makes you question what we thought we knew about AI and the importance of sheer size.
It does, and it raises some interesting questions about the nature of intelligence itself.
Yeah,
Are we too focused on just replicating the scale of the human brain
right.
rather than understanding the principles of how we think and learn?
Maybe we need to shift our focus from brute force to finesse
I think so.
instead of just building bigger and bigger models.
Yeah,
We should be exploring how to make smaller models smarter, more efficient, and adaptable.
I agree. I think that's a key takeaway from this research.
Yeah.
It's not just about size, it's about strategy efficiency and the ability to learn and adapt.
And that's something humans are remarkably good at.
Yes, very true.
We're incredibly adaptable creatures.
Mm-hmm.
We can solve problems, learn new skills,
Yeah.
thrive in all sorts of challenging environments,
Mm.
all without having the biggest brains on the planet.
Exactly. We've evolved to be efficient and resourceful.
Right.
And maybe that's a lesson we can apply to AI development.
Yeah.
Instead of always trying to replicate the scale of the human brain, we can focus on emulating the elegance and efficiency of our thought processes.
It makes you wonder if there's a sort of cognitive efficiency we can learn from,
Right.
both in nature and these new AI models.
Yeah, for sure.
But I have to admit, I'm a little curious about why the researchers chose to focus on math problems for this research.
Yeah.
Why not something like language translation or image recognition?
That's a great question.
Yeah,
There are a few reasons why math problems are a good choice for this type of research.
okay,
First, they have well-defined solutions.
okay.
There's usually a clear right or wrong answer,
Mm-hmm.
which makes it easier to evaluate the AI's performance.
So it's a more objective measure
Exactly.
of its reasoning abilities.
Right,
It's not as open to interpretation as something like,
right.
writing a poem or composing a song or something.
Exactly.
Yeah,
Second, math problems often require a series of logical steps in deduction.
okay.
They're not just about memorizing facts, but about understanding concepts and applying them in new ways.
So it's about demonstrating true understanding, not just pattern recognition.
Right.
Okay.
And finally, math problems can be easily scaled in terms of difficulty.
Okay.
The researchers could start with simpler problems and gradually increase the complexity to really put those AI models to the test.
It's like a training regimen for AI,
Haha, yeah.
starting with basic exercises and working up to like
Exactly.
Olympic level challenges.
I like that analogy.
Yeah.
And by using these math problems, the researchers were able to really assess not just the AI's ability to solve problems,
Uh-huh.
but also its ability to learn and adapt as those challenges became more difficult.
This research is definitely challenging a lot of our assumptions about AI.
It is. It is.
It's exciting to think about what this could mean for the future.
Yeah.
What are some of the potential applications that you're most excited about?
The possibilities are really endless.
Yeah.
Imagine AI-powered tools that can help doctors diagnose diseases earlier and more accurately,
Right.
personalize education for every student,
Mm-hmm.
even assist us in tackling complex global challenges like climate change.
It sounds like this could be a real turning point in how we develop and use AI,
I think so.
moving away from a reliance on massive computing power
Right.
and towards more efficient, accessible solutions.
Yeah,
It's really inspiring.
it is. But as with any powerful technology, we need to think carefully about how we develop and deploy it. As we create smarter and more capable AI, we need to make sure it's used ethically and responsibly for the benefit of all humanity.
It's a responsibility we all share.
Absolutely.
We need to be asking those tough questions about the ethical implications of AI
For sure.
and work together to create a future where this technology empowers us, not overwhelms us.
That's a great point.
Yeah.
It's not just about the technology itself, but our values and how we choose to use it.
Well, this has been a fascinating deep dive into the world of AI
It has.
and the potential of smarter, smaller models.
Yeah,
Thanks for taking us on this journey.
my pleasure.
And remember, the most important thing is to stay curious and keep exploring.
Absolutely.
Until next time, keep those brains buzzing.
Okay.